Good day, students. Welcome to part 2 of the edexcel GCE Core Mathematics 1 exam for January 2012. We're going to be going over questions 3 and 4. All right, let's go ahead and take a look at question number 3. It says, find the set of values of x for which the a part is 4x minus 5 is greater than 15 minus x, and the b part is x times x minus 4 is greater than 12. So you get 2 marks for the a part and 4 marks for the b part. All right, let's start with the a part. This one is assessing your ability to solve linear inequalities with variable on both sides. So we have 4x minus 5 is greater than 15 minus x. So we're going to solve it as though we're solving an algebraic equation with variables on both sides. So I like this x collected on the left side, and then this 5, I need to move it to the right side. So I'll just add x to both sides, and I'll have 5x minus 5 is greater than 15, and then I'll just add 5 to both sides, and that gives me 5x is greater than 20. Right now, 5x is greater than 20. All right, and then to finally isolate x, I'll divide both sides by 5, and then I'll have x is greater than 4. Okay, 20 divided by 20 is 4. So there goes your answer to question number 3A. Okay, now let's go ahead and work on the B part. The B part is a little bit more involved. That one actually involves working with a quadratic inequality. So let's write down the question for part B. We're solving the inequality x times x minus 4 is greater than 12. All right, so the easiest way to solve this is to compare it to 0 and then see what values of x make the statement true. Okay, so to make this, compare this to 0, I need to distribute the x to these two terms in this parenthesis. So we have x squared minus 4x is greater than 12. Now we need to get this compared to 0, so I need to move this 12 to the left side, so I subtract 12 from both sides. So that yields x squared minus 4x minus 12 is greater than 0. Okay. Now I'm going to go ahead and factor this quadratic expression on the left side, and then we can then look at the factors to see where the sign changes happen. So I'm going to use the x factor method. I'm going to have the product of a and c on the top, negative 12, and then the middle term goes on the bottom, negative 4. Okay, this is a, which is 1, and then this is b, 4, negative 4, and c is negative 12. Okay, so what numbers multiply to give you negative 12 and add to give you negative 4? 6 times 2 is 12. Let's make the big one negative. So this combination kind of works, all right? So the factored form for this quadratic expression is x minus 6 times x plus 2 is greater than 0. Okay? Now what I'm going to do is I'm going to set each factor to 0 and solve. So we have x minus 6 equals 0 and x plus 2 equals 0. If I solve this by adding 6 to both sides, I'll have x equals 6. And if I solve this by subtracting 2 from both sides, I'll have x equals negative 2. All right? Now what I'm going to do is I'm going to make my number line and create intervals where I'm going to test, okay? So there goes my number line. My boundary points are negative 2 and 6. These are boundary points because this expression equals 0 at these 2 points, okay? So what I'm going to do is I'm going to test values in interval 1, 2, and 3. I'm going to test them against the original equation, and whichever one is true, that will be my solution, part of my solution region, okay? So I'm going to test it against this equation, x times x minus 4 is greater than 12. This is the original problem. Okay, so let's pick a candidate for interval 1. A number that's less than negative 2 is negative 3. And then a candidate for interval 2, a number between -2 and 6. An easy number to pick is 0. And a number to the right of 6, something like 7. Okay? All right, let's go ahead and test them. So let's start out by we're going to test x equals -3. So I'm going to plug in -3 into this inequality and see if we arrive at a true statement. So we're going to have is -3 times -3 minus 4, is it greater than 12? Is this true or false? Well, let's see. -3 minus 4 is -7. Is that greater than 12? -3 times -7 is +21. Is +21 greater than 12? Is it? Absolutely. So that means this interval right here, interval number 1, this interval is good. Okay? The next thing we're going to test, let's test x equals 0 in the same equation, and then see if we arrive at a true or false statement. Okay? Alright, so let's go ahead and do it. So the question is 0 times 0 minus 4 greater than 12? Is it? Is 0 times -4 greater than 12? Put the question mark there because we don't know yet. If I times this, is 0 greater than 12? Absolutely not. So this is a false statement. That means this interval number 2, is bad. Alright? So the last test we're going to do is interval 3. Interval 3, we're going to test x equals 7. And then the question is 7 times 7 minus 4 greater than 12? Well, let's work it out. Question mark. Is 7 times 3, is it greater than 12? 7 times 3 is 21. Is 21 greater than 12? Absolutely. So that interval is good also. So intervals 1 and 6 are good. So basically this interval from here, interval 1 is basically this going the numbers, every number from that's less than -2. Remember, we cannot include -2 because our inequality doesn't have a line under it. If it had a line, then we can include the boundary points, but it doesn't have a line under it. And then the second interval is to the left. Okay? So what is the name of this interval? To name this interval right here, every number that's less than -2 is written as x is less than -2. And then for this interval, every number that's bigger than 6 is written as x is greater than 6. Okay? So for this problem, our solution is basically x is less than -2, which is interval 1, and x is greater than 6. Alright, so there goes your answer to the B part of number 3. Alright, now moving right along. Alright, so for question 4, we have a sequence x1, x2, x3, on and on, defined by x1 is equal to 1 and xn sub 1 is equal to ax sub n plus 5, where n is greater than or equal to 1, and a is a constant. Part A says write down an expression for x2 in terms of a, and you get 1 mark for that. So let's go ahead and do the a part. If we want to write down x2 in terms of a, all we just simply do is we're going to plug in n equals 1 into this equation. Okay, so if I plug in n equals 1, I'm going to have so plug in, this is for the a part, plug in n equals 1. If I do that, I'm going to have x sub n plus 1, x of 1 plus 1, because I'm going to replace that n with a 1. So x of 1, let me put that in blue so you can see it, 1 plus 1 equals a x sub 1 plus 5. Okay? So to get x of 2, we have to plug in 1 into the subscript. Alright? So we're going to have, or the index, we're going to have x of 2 is basically equal to a times x of 1 plus 5. Alright? Now, we also have another piece of information, which is that x of 1 is 1. So if x of 1 is 1, we're going to substitute that value into this equation right here. So we're going to have x of 2 equals a times 1 plus 5. And then if we simplify that a little bit, we'll have x of 2 equals a plus 5. So that goes the solution to the a part. Alright, now for the b part, we have to show that x of 3 is equal to a squared plus 5a plus 5. So for the b part, what we need to find first is we want to find out what x of 3 is. Okay, so x of 3, using the formula, x of 3 is basically going to be x, so 2 plus 1, so 2 plus 1, which equals ax, so 2 plus 5. In this case, we're plugging in, we're going to plug in n equals 2 in this case, okay? So let's simplify that a little bit. So we're going to have x of 3, which is what we're looking for, equals ax of 2 plus 5, all right? Well, we know from part A that x of 2 is a plus 5, so we can make that substitution here. So we're going to have x of 3 equals a times a plus 5 plus 5. Okay, I substituted the value of x of 2 in part A in here, and then I can simplify this. I just distributing this a to these two terms in a quantity, so x of 3 is basically a squared plus 5a plus 5. Alright, so there goes the expression for x sub 3. Okay. Now for the c part, we have to find all possible values of a, given that x of 3 is 41. So all we just simply do is set x of 3 to 41, and then solve that resulting equation. So for the c part, we have x of 3 equals 41, which basically means that a squared plus 5a plus 5 equals 41. So I want to solve this using as a quadratic equation. So to do that, I need to set it equal to 0. All right. So to set it equal to 0, to find the zeros, I just need to subtract 41 from both sides. And then we have a squared plus 5a minus 36 equals 0. All right. So let's solve this. I'm just going to make the x game. To factor this quadratic trinomial, AC goes on top, B goes on the bottom. AC is negative 36, and then B is 5, because A is 1, this is A right here, this is B, and this is C. Alright, so what works here? What two numbers multiply to give you negative 36 and have to give you 5? 9 and negative 4 works, okay? So we're going to have the factored form of this expression on the left side is a plus 9, write my a differently, times a minus 4. Okay, so we're going to use the zero product property. We set a plus 9 to 0 and a minus 4 to 0 also. Alright, so to finish this up, I'll just subtract 9 from both sides, and then we'll have a equals negative 9, and then from this side I just add 4 to both sides, and I'll have a equals positive 4. So the values of a are either a equals negative 9 or a equals 4. So there goes your answer for x of 3 equals 41. Alright, so there you have it.